Welcome back to STS. In today's video, we're going to use the difference quotient to find the slope and the equation of the tangent line to the graph f at a particular or at a given value of x. In this particular example, our function f is negative 3x plus 25, and they're giving us a value of x being 3. Before we begin with the difference quotient, let's notice that this here, negative 3x plus 25, is a linear equation. We know that because we have a single variable, and that variable is being taken to the first power. So with that, we know we have a straight line. Being that it's a straight line, if it's in the form y equals mx plus b, then we know that the value of m would be the slope, which is basically the coefficient of the x term, and here we see that coefficient is negative 3. So before we use any calculus or any difference or the difference quotient, we know that the answer is negative 3. But let's continue to just, as the exercise show, that the difference quotient still brings us to the same conclusions. First thing I want to do is to do a input of the positive 3 so that we can get the y value. And again, we know that f of x is the same thing as y. So here we're going to say f of 3, because that what was given, is equal to negative 3 times 3 plus 25. Negative 3 times 3 gives me a negative 9. I need to add 25 to that, and that gives me a value of 16. So my point of tangency is actually 3/16. So let's box that in. And the next thing I want to do is go ahead and define or show the difference quotient. The difference quotient is just giving you the, or just calculating the derivative of a particular function. So here it's f of x is equal to f of x plus h minus f of x, where all that is divided by h. And of course I'm going faster, so I left off that that's really the limit of that as h approaches 0. So all this here is the difference quotient. If you look back at some of my videos on other videos on YouTube, you see I have a video where I actually derive this difference quotient. Alright, now let's go ahead and put this difference quotient to use. Alright, let's begin by rewriting f prime of x is equal to the limit as h approaches 0. Here, this first portion of the difference quotient says that take the function f and make the input x plus h, which simply means wherever there's an x, change that x into x plus h. So here I have negative 3 times the quantity x plus h plus 25. That's the first portion of the difference quotient, minus, so I put the minus here. I have two terms in my original equation, so I'm going to need parentheses. So negative 3x plus 25. Again, the parentheses ensure that both of these signs will be changed when I distribute that negative. And here everything is divided by h. Again, I rewrite so I can begin to resolve. So the limit as h approaches 0, I distribute this negative 3 to get negative 3x minus 3h plus 25, and distribute this negative, which changes both of those signs, positive 3x minus 25, and everything here is divided by h. At this point, I should have some terms cancel out. If you're not canceling terms, then you've definitely made a mistake somewhere. So I've got the negative 3x and a positive 3x, so those go away. A positive 25 and a negative 25, so those go away. So I'm left with the limit as h approaches 0 of negative 3h over h. Again, I just have the remaining terms. H divided by h cancels down to just 1. So I have the limit as h approaches 0 of negative 3. And when you take the limit of a constant, that constant is your result. So here I have negative 3, which is just what I thought it would be. Let's quickly call up the calculator, and I've already done the information, but I want you to take a look at it. So here on the calculator, we'll notice that I've already graphed the function y equals negative 3x plus 25, and I've gone ahead and found that the derivative at the value of x being 3 gives me a negative 3. Let me quickly re-show you how to do that. You press y equals to put in the function. You press graph to graph the function. Then you're going to press second and then calc, which is the trace button, and you're going to go down to 6, which is going to give you the derivative, or allows you to figure out what the derivative is at a particular point. Here it's already set to 3. It's not going to usually be where you want it to be. I moved it there. So here you see I move it to 3, and then once I press enter, we see that we find the derivative at this value at the x value of 3 gives me a -3. Alright, let's return back to the handwritten portion. The second part of this is to find the equation of that tangent line. So let's begin by just restating the slope-intercept form, which is y is equal to mx plus b. Here we know that y is 16. We figured out that m is the -3, also down here. We know x is the +3 plus the y-intercept, which is known as b. So I have 16 is equal to -9 plus b. Now I'm going to add, now I'm going to add 9 to both sides so I can isolate b by itself. These 9's cancel, and I have 25 is equal to b. Now I rewrite it for the equation of the line, so it's y equals -3x plus, and the b is 25. And notice that this equation here is the same equation that we have when we started the problem. And all this means is that with a linear equation, the slope is constant for the life of that equation. So it only makes sense that these two equations match exactly. Alright, that sums it up for this video. Please subscribe to our YouTube channel, and as always, thank you for watching.